So far, we've learned how to add, subtract, multiply, and divide our rational expressions. What we're going to focus on now is the graphs of rational functions. So rational functions are when you have polynomials in both the numerator and the denominator. So if we take a look at a very basic graph of a rational function, I have f of x equals 1 over x. What I'm going to do is fill out a table of values and examine what's going to happen in this graph. So if I take 1 over 1/4, I would get 4. If I take 1 over 1/2, I would get 2. If I do 1 over 1, that'd be 1. If I do 1 over 2, that's 1/2. So if I flip it around and do this side, if I start to work with negative 1/4, negative 1/2, negative 1, negative 2, if I do 1 over negative 1/4, I would get negative 4. If I do 1 over negative 1/2, I would get negative 2. 1 over negative 1 is negative 1, and 1 over negative 2 is negative 1/2. And so what I'm going to do is I'm going to graph these, and then we'll look at what happens with our calculator when we do this. So if I take a look here, I'm going to go each one of these dashes as, we'll say, 1/4. So here is negative 1. Here is negative 2. And here is negative 3. And I'm going to do the same thing on this one. So I'm going to go over 4. Here's 1. Go over 4. Here's 2. And here's 3. Now on my y-axis, I'm going to use a different interval. I'm going to go up by 3s. So here's 1. Here's 2. And then we have here's 3. And here's 4. Same thing, I'm going to go down. Here's negative 1. Here's negative 2. Here's negative 3 and negative 4. Now I'm going to plot my points. At positive 1/4, right here, I am all the way up at 4. At 1/2, I am at 2. At 1, I am at 1. At 2, I am at 1/2. So if I'm at negative 1/4, I'm all the way down to negative 4. If I'm at negative 1/2, I'm at negative 2. At negative 1, I'm at negative 1. And at negative 2, I'm at negative 1/2. Now what I'm going to do is I'm going to connect these with a curve. And I notice if I'm connecting with a curve, and I'll come down this way, it starts to, as I get to the value of 2, looks like level off. So I'm just going to keep on going and level off at the end. And it's the same. If I were to go up, I start to see, well, it looks like it's approaching this y-axis. It's the same here. So I'm going to come up with a curve, go through all the points. I'm going to level off. And as I go down, I'm going to level off towards the y-axis. And so we notice here there's something different. We don't just have one curve, we have two curves here. And it looks like it levels off here at the y-axis, and it looks like it levels off here at the x-axis. What those are called are their asymptotes. So you have, when you're graphing rational functions, you have asymptotes that are going to be created. You have the possibility of what we call vertical asymptotes, horizontal asymptotes, and sometimes the possibility of a slant asymptotes. Now what's interesting is I'm going to talk about this vertical one because it's the easiest one to see. The vertical one exists because of our definition. When you have a polynomial, the denominator cannot be equal to 0 because otherwise you're dividing by 0. And so that is why we have this vertical asymptote. That's why our graph approaches x equals 0, the y-axis, but does not touch it, because then you would have a denominator of 0. So what I want you to see here in this introduction, we're not covering too many of the concepts. We're just showing you what a graph of a rational function is going to look like. In the future videos, we're going to examine how to identify the asymptotes, a line that the graph approaches but never touches.